4 decades, NASA has launched telescopes into space, but the James Webb Space Telescope (JWST) is the first that can compete with its capabilities. Despite its hefty price tag and protracted development time, as an observing facility, the JWST has never been looked at with such anticipation. However, the larger, more powerful telescope is already proving its value with a startling discovery concerning the warp bubble. Just what is a warp bubble anyway? So, what has the JWST uncovered thus far? The expanse of space contains many intriguing destinations. The universe is filled with innumerable galaxies, black holes, and other objects such as exoplanets. The human race is a curious one, always looking to expand their knowledge of the world around them. Inquiring minds want to know what lies beyond. Is it possible that some of the aliens we share the universe with are on a par with us cognitively? Is there any chance that we have found an exoplanet with microbial life? However, the vastness of the universe presents a challenge to space exploration. In the grand scheme of things, Mars isn't that far away. But before landing on their new home world, volunteers for Elon Musk's colonization attempt will have to undergo more than 5 months of transit through the hazardous environment of deep space. Suppose you want to use present technology to travel to Proxima b, the exoplanet that is closest to Earth. It's wishful thinking to imagine that the distance to the exoplanet from Earth, 4.24 light-years, can be covered easily. To put it another way, the nearest exoplanet is around 25 trillion miles away. A light-year is 5.88 trillion miles, so that's not going to work out at all. This, however, will not deter us from further exploration. After all, we have already found ways to reach faraway stars using astronomical telescopes. Even if we are unable to physically approach these objects, we may be able to learn more about them by sending powerful eyeballs in their direction. The practice of launching space telescopes by NASA dates back many decades. The Hubble Space Telescope is one of the most well-known telescopes, used by astronomers to study distant regions of the universe as it orbits the Earth. When it comes to the warp drive, though, NASA is the type of organization that can't help but keep launching satellites. Humanity now has a new tool to examine distant cosmic objects, one that is significantly more advanced than any previous space telescope. The James Webb Space Telescope will take the position of the Hubble as the most powerful observatory in space. The JWST has allowed astronomers to peer farther into the past, examining the process of star formation around the time the universe was born. It's 100 times more powerful than Hubble, allowing us to peer back in time beyond the debilitated star's 330-million-year-old view of the universe's beginnings. If you're wondering how the JWST can see billions of years into the past, it's because light from faraway stars has taken billions of years to reach Earth. The distant stars seen in this light from a distance of trillions of kilometers reveal their appearance billions of years ago, even though some of them may have already passed away. NASA has released the first batch of photos to showcase the JWST's potential. Included are the bright regions of space known as the Carina Nebula. Several brilliant stars, many times the size of our Sun, reside in a billowing cloud of gas and dust located about 7,600 light-years from Earth. The Stephan's Quintet, a cluster of galaxies roughly 1,000,000 light-years away, will also be visible in the photos. 4 of the 5 galaxies in this group are engaged in a complex dance, their shapes warped by the mutual attraction of their gravity. Amazing pictures of the galaxy cluster SMACS 0723 will soon be available. The light from objects behind this cluster of galaxies is warped and amplified by the cluster's own galaxies, making it a truly unique phenomenon. This property allows telescopes to detect faint, faraway galaxies. In fact, this is where the JWST really excels. However, the warp bubble is unlike any other discovery that the JWST will make. First, we'll define this concept of a warp bubble. Although a thorough grasp of this topic necessitates strong mathematical understanding, we shall make do with a simple definition for now. You're not technically going faster than light when you travel in a warp bubble. Rather, you're simply surfing a bubble of condensed space that is compressed in front and expanded in back. This propels the bubble and its contents forward at speeds greater than the speed of light. Why make such a big deal out of warp bubbles, you may ask? That's because they solve a major problem associated with traveling faster than the speed of light, which causes time to pass more slowly. Imagine you had the ability to exceed the speed of light. Everything outside your ship would speed up, making a 3-hour visit to a tropical paradise feel like years on Earth. If you wish to obey all known physical rules and travel faster than light, you should probably end all your relationships before you go. Warp bubbles, on the other hand, don't have this problem. The space inside the bubble doesn't change, so even if you're flying at warp speed for an hour, it's still only an hour for everyone else. Warp speed is a concept well known to Star Trek fans. Since the first episode aired in 1966, there have been 10 television series and 13 films set in the Star Trek universe, all of which contain the fantastic future technology known as warp drive. The story's protagonists travel from planet to planet in fast, powerful spaceships while exchanging messages with an alien crew. It's the torsion engine that draws people in, as the plot wouldn't hold water without it. The universe is strange, mysterious, and absurdly large. Even if you wanted to travel to the next star, the enormous distances between them would be nearly impossible to traverse. The next star we can examine is Proxima Centauri, located 4.5 light-years away. Traveling at the speed of light, getting to the star would take about 4.5 years. Any other method is slower because light travels at full cosmic speed and acts as a form of universal speed limiter. Staying close to Earth and its neighboring environment makes sense because even with the fastest space probe developed, the long trek into the intergalactic abyss would take around 8,000 years. The Star Trek crew didn't stick close to home because they figured out how to cut down on their trip time. Therefore, they didn't bother sticking around Earth. Space and time are juggled by the torsion engine, which employs warp drive technology, and the result is thrilling. Prior to the final years of the last century, scientists had resigned themselves to the idea that a warp drive was impossible. Where do warp bubbles fit into the grand scheme of things? Let's check out Proxima Centauri, the nearest star to Earth, which is located 4.25 light-years away. That's around 25 trillion miles or 40 trillion kilometers. With a peak speed of 450,000 miles per hour, the Parker Solar Probe will be the fastest spacecraft ever built. Extremely fast, as it only takes 20 seconds to get from Los Angeles to New York City. But it will take you almost 6,663 years to get to Proxima Centauri. However, if you use warp bubbles, you can conceivably reach Alpha Centauri in 1 month as determined by the spacecraft's onboard clock and Mission Control's master clock. Miguel Alcubierre was the physicist who, in 1994, came up with a notion that shocked the scientific community around the world. While working on his doctorate thesis on Einstein's general theory of relativity, Alcubierre was inspired by an episode of Star Trek, The Next Generation, in which heavy masses can bend space and time. He immediately grabbed a scrap of paper, did the calculations, and subsequently published his findings in a scientific journal later that year. In his study, Alcubierre explains how to visualize a torsion bubble in which space and time are compressed in front of a spacecraft and stretched back behind it, making the journey to the destination much quicker. In any case, Alcubierre's warp bubble has certain issues. You see, aggressively curving space with regular mass isn't enough to power a warp engine. You need exotic matter with negative gravity to reduce travel times. Alcubierre's warp drive would encase the spacecraft in a bubble of flat spacetime and then twist spacetime around the bubble. If a warp drive were to function, it would require either the theoretically possible form of matter known as negative mass or a ring of negative energy density. However, as negative mass has never been seen by physicists, this leaves us with only the latter possibility. Negative energy can be generated by a warp drive by creating an imbalance between particles and antiparticles, which requires a large quantity of mass. Alcubierre's warp drive would use this negative energy to create the spacetime bubble. However, to generate enough negative energy, a warp drive would require a large amount of matter. Alcubierre estimated that a warp drive with a 100-meter bubble would require 1 × 10 superscript 3 kg of matter. It seems like you shouldn't enter this area. Fans of the warp drive have another reason to believe they will live to see a real warp drive constructed. In the traditional way of discovering things, the way to build a working warp drive may have been discovered by accident. Warp bubbles seem like a concept that will never be realized in the real world, but a completely coincidental discovery is reigniting interest in the concept and could prove to be a breakthrough. Dr. Harold White is a researcher for the Defense Advanced Research Projects Agency, DARPA. The EagleWorks laboratory in Texas is where he and his colleagues first began publishing their findings on the potential structure of the energy stored in a Casimir cavity. The article states that White and his colleagues found a micron nanoscale system that can anticipate the distribution of negative energy density. This appears to be the system Alcubierre needs to work on. Simply put, White and his co-workers were doing a microscopic experiment when they discovered something unexpected while looking into a theory proposed by Dutch physicist Hendrik Casimir regarding the dispersion of energy across wavelengths. According to White, the group's custom Casimir cavities were subjected to careful numerical analysis, which led them to the identification of a real, manufacturable nanoscale structure that is predicted to generate a negative vacuum energy density and, as a result, manifest a real nanoscale warp bubble structure. Not an analog but the real thing. Alcubierre's concept of warp speed was theoretically possible thanks to the amount of energy produced in the experiment. White was also familiar with Alcubierre's plausible suggestion for a warp drive that could travel faster than the speed of light without violating generally accepted physical principles. However, he also knew that the plan had been ridiculed for its reliance on unrealized theoretical materials and massive amounts of energy. White refined Alcubierre's initial metric and changed it into a canonical form, which drastically reduced the requirement for unconventional materials and energy. The revised idea resulted in the original theoretical design being informally renamed and is now more often known as the Alcubierre-White warp drive. Additionally, it provided scientists and fans of science fiction with hope that a practical warp drive could one day be built. White predicts that his or another scientist's small warp craft will be built and tested soon. However, White is quick to point out that much more research is needed before we can develop a completely functional warp drive. Yet there is some reason to believe that one day humanity may be able to travel the galaxy at light speed in a warp bubble, a la Star Trek. What are your thoughts on the concept of warp bubbles? Let us know in the comments. Thank you for watching this video until the end. If you liked it, please leave a like and subscribe to our channel to make sure you don't miss any space news. Let us take you on another journey through the cosmos. Click on the video on your screen and I'll see you there.